Oh, hey, I didn't see you there. I'm Steve Kearns from the product management team here at Elastic, based in Boston, Massachusetts. I just wanted to say thank you.
The Elastic community is about more than just
meetups,
t-shirts,
hoodies, stickers,
lots of stickers,
and commits. Lots of commits.
Right. What really makes our community
is you.
So, thank you.
Thank you.
Thank you.
बहुत बहुत धन्यवाद मिक्का नंड्री చాలా కృతజ్ఞతలు తమాషా అనేక ధన్యవాదాలు
Thank you.
Thank you.
Arigato.
Grazie mille.
Just really, thank you for everything.
Hi, this is the Seoul Elasticsearch community. We love Elastic.
Mijn naam is Gabriella en ik werk niet bij Elastic, maar mijn vader wel. Ik hoor hem praten over de Elastic Stack. Maar meestal hoor ik hem praten over de gemeenschap en hoe belangrijk het is. Van onze familie tot u. Dank u. Oh, vertel hem ook dat hij Nederlands moet leren. Het wordt best wel beschamend.
Tusen tak. Merci beaucoup. Hartstikke bedankt. Muchísimas gracias. Thank you so much.
大家好，我是 Elastic 在中国的工程师真勇，感谢你们使用我们的软件。
谢谢大家，我爱你们。
To everyone in the open source community who's contributed to the Elastic Stack, you do an amazing job. Everything from big features down to tiny little changes. It's all massively appreciated. Thank you very much.
Fancy. I wanted to say thank you to our community, and to do that, put on my white tie, went to a ball just to make it special, just for you. Thank you.
谢谢使用 Elastic， 多謝使用 Elastic。 Thanks for using Elastic.
Merci beaucoup.
Merci beaucoup.
Elastic, 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 and we the open source stack. We gon' get you on track. These beats Cabana lock.
Oh, this is embarrassing. Just getting amped up for ElasticCon 2018. And on behalf of everyone here, I just want to say thank you for all that you do.
Thank you.
Danke, merci, grazie, grazia, thank you.
I want to say thanks to all our community members who helped us build an awesome product. תודה רבה.
여러분, 정말 고맙습니다. Thank you so much. You are awesome.
Thank you everyone. You are an awesome community.
From London, but in Greek, ευχαριστώ πολύ.
コミュニティの皆さん、コントリビュートしていただいた皆さん、本当にありがとうございます。これからもよろしくお願いします。
Thank you for all of your help.
Thanks. You rock.
Merci.
And I wanted to thank you, the community, for everything that you've done to make this possible. Thank you so much.
Thank you, Okini.
Muito obrigado.
I just want to say thanks very much for being awesome community members. It makes the job absolutely fantastic and amazing. Keep up the great work. Cheers, mates.
Thank you for being our users and customers.
Thank you for coming to ElasticCon.
You all are what make our job great.
Thanks for being amazing.
Hi, I'm Tony.
And I'm Daniel.
We both write for the marketing team.
And we're both based out of Seattle.
We want to send damp Pacific Northwest hugs out to the Elastic community we love so much.
Please hug us back. It's so cold and dark here.
Thank you.
Thank you so much for being so wonderful to work with.
Thank you.
Thank you for sharing how search powers your world, for showing us that cool use case of your data, for making that data more accessible and sharing that knowledge with others, and finally for inspiring us to all search for that needle in a haystack. Thank you.
Are we saying on three? Ready? 1, 2, 3. Thank you. You.
Oh. Ooh. This is a you.
Ladies and gentlemen, please welcome Shai Bannon.
Hi, everybody. Well, if I can add to the video here, thank you very much for joining us here today and joining us on the live stream or watching on the replay. I'd like to add to the thank you for all of you for using our software, using our products, and being part of our community. I think one of the beautiful things of open source is the fact that there's no cost for you to just go and download and experience the products that we build, which means that we can be as distributed as you want us to be. And I'm extremely proud also, to be honest, in a moment of self-reflection, it's about the company that we're building in Elastic and how distributed we are as a company that you've probably seen in the video. We have more than 800 employees now. And those employees are spread across 34 different countries, speaking more than 30 languages. And it's a pretty fascinating experience to try to build a company that matches the community that we end up serving. So back into our products a bit. So it started a bit with Elasticsearch way back 8 or 9 years ago. And since then, we've grown as a company and basically just grew up with you, our users. We've added Logstash and Cabana as products that ended up being developed around Elasticsearch as the ecosystem of Elasticsearch grew. And we started to have this thing with stacks, to be honest. Initially, it was called the Elk stack, and it was Elasticsearch, Logstash, and Cabana. And we loved the Elk stack, but we also kind of didn't like it that much. I think one of the biggest reasons why we struggled with the notion of an Elk stack is that we didn't want to constrain you, the users, with all the possibilities that we truly believe that search as a technology can solve, all the use cases that you take search and actually apply it to all of the various use cases. Logstash and Cabana and all the other tools that ended up being developed on top of it are just part of everything that you do every day. And we'll be remiss to take just the Elk stack and constrain what we do just for logging or just for security or just for another use case. So we changed it a bit to Elastic Stack. But many times we as developers or builders of products tend to have this unhealthy fascination with naming. But to be honest, at the end of the day, it's about what you, the users, end up taking our stack and end up using it for. And whether it's the Elk stack or the Elastic stack, it doesn't really matter. You take our software, you take our products, download it, and run it as a hosted service and use it to solve a real-world problem. And that hopefully ends up creating value to what you're trying to do. And through that value and through that success, and whether you downloaded it to add a search box to your website 8 years ago, or to take a log file that was sitting somewhere unattended for, and then suddenly being able to get visibility into what it's producing, all of these end up bringing you value. And you download that software and actually use it to solve a real-world problem. You didn't download a platform, you didn't download a data lake or something like that. You actually downloaded the product that brought you value. And that's what we try to do with you, our users. And through that value, you end up using us and trusting us to solve other type of use cases as we grow with you, our users. But in order to be able to build these products that have this very weird duality, and it's a tough one, around being able to build a product that has the platform and has the capabilities to solve many different use cases, but still be usable at the same time. And over the last year, tons of investment have gone into our products when it comes to trying to build a stack, build this set of products, Elasticsearch, Beats, Logstash, Cabana, client libraries, that ends up enabling you to solve all of these various use cases. And being able to go and take one feature, use it for one use case, maybe a second use case. But to be honest, the thing that I'm most excited about is the ones that we don't think about. It's about you, the users, taking another feature, saying, you've proven the value and you've shown us that you can solve these two other use cases. Let's give you a chance with this one. And that's how we grow with you. So as you can see, there's tons of features here. But let us focus on 3 of them. But first, I hope that you notice that we have exactly 10 laptops here. So we're going to have a busy day when it comes to showing off what we've been building over the last year. So hang with us when it comes to it. So the first feature when it comes to shaping a stack, these generic features that we believe that apply for many different use cases, is rollups. So rollups is a very interesting feature. I admit I had a lot of problems with the notion of rollups historically. If you think about a search engine, the power of a search engine is the ability to take 100 attributes for a specific data point and being able to slice and dice your data however you want to see fit. And whether that data comes from yesterday or whether that data comes from 10 years ago, that freedom and that ability to go and slice and dice your data is very empowering. Now, if you look at rollups and why do people want to roll up data, they want to save on space. They want to be able to go and save on space when it comes to 10-year-old data versus data from yesterday. The challenge with rollups is that you've predefined how you want to look at your data. And what happens if you roll up your data from 10 years ago and suddenly you realize that there's one dimension that you want to look at your data, but you can no longer do it when it comes to, because you've just rolled up your data. So there's value in rollups, and there's challenges with rollups. So over the past few years, what we've done is we've focused on trying to make our system best when it comes to not necessarily needing to use rollups, whether it's through compression, whether it's through being more efficient of storing data, but whether it's through being more efficient when it comes to querying and analyzing large amounts of data. But this year, we felt like it's time to focus on rollups. And I'm super excited because I've actually stepped into this project with our team, and I had my concerns around rollups, which I mentioned before. And it's pretty impressive how we looked at rollups. And like everything that we do in Elastic, we put our spin into it. I'd like to welcome Zach on stage to show the rollup feature in Elasticsearch. Zach?
Thanks, Zach. Hey, everyone. So to show you how the rollup feature works, we're going to do some good old-fashioned curl demoing here. And we've got a metric beat index on my laptop. It's got about 9 million documents, roughly 2 gigabytes in size. And it's basically metric beat data that you'd expect, right? So there's different modules that are enabled. Each module emits several different documents per second. And it's filled with essentially a bunch of numeric values that you'd like to keep around. And the goal of the rollup is to take all this metric beat data and compress it to something much, much smaller, but still make it useful in the future. So I'm going to go ahead and run this so it can go and process in the background while I talk. And let's look at how rollups actually work. So this rollup job configuration right here is how you set up the rollup in the system. And basically, a rollup job is a process that runs in the background and continually looks over your data and aggregates it into summary documents. You define an index or index pattern that you'd like to roll up. So in this case, metric beat -*. And you tell it, I would like to stick all those rolled up documents into the rolled index. You give it some type of cron schedule so that it runs every hour, or maybe at midnight. And then this process basically just runs in the background and churns through your data. The rest of the configuration is basically what you'd like to roll up. So there's two sections here. There's the groups and the metrics. The metrics are pretty straightforward. These are numeric values inside the documents that you'd like to collect, say, the min or the max or the average of. And these are really cheap to save. So we usually just save all the numerics we can find in all your documents. And then if you go back up to the groups section, the groups are essentially which fields you would like to run future aggregations on. And what's important about the rollup system in our feature as opposed to other systems is we don't want you to define specific charts that you're interested in, right? So other systems, you often have to say, I'd like the average CPU on an hourly basis, and then you get a chart for it. But what if you need average CPU partitioned by host name on an hourly basis, or a daily basis, or any of the other combinations? You have to define those charts explicitly up front, otherwise you've lost your data, you can't really use it. So we took a different approach where we say, don't define charts, just define the fields you're interested in and the aggregations that you'd potentially like to run searches on at a later date. So here we've got a timestamp field that we'd like to run a date histogram on at some point using hourly intervals. And then a whole bunch of numeric and keyword fields that we'd like to run terms aggregations on. And this is stuff like the process name or the what metric beat module it came out of. All right, so that job should be done now that we started. Yep, so that is finished. Let's take a look at, see what it actually created. Oh, let's refresh that. There we go. So you can see that the original index, we still have that. It's 9 million documents. But there's a new rolled index, which has about 50,000 documents and 27, 30 megabytes in size, which is considerably smaller, right, than what we started with. Now, of course, it's easy to get good compression if you just delete data. So we need to be able to use this very small index for something. So if you look here, we've got a query that looks just like a normal Elasticsearch query, right? We've got a term query at the top, there's a date histogram aggregation, there's an average metric aggregation, and this looks exactly like you'd expect in a normal search. The only difference is it's going to this rolled index, and it's going to the underscore rollup search endpoint. So there's a slightly different endpoint that you use, but the same syntax otherwise. And we can execute that. You can see that it gives you a response, which is basically what you'd expect. There are buckets. Inside the bucket, there are keys. Inside each bucket, there's the metrics that you asked for. And this is really important to the rollup feature. We wanted the request and the response syntax to be basically identical to a normal search so that it's as close to a drop-in replacement as possible for your dashboards. Now, of course, you could just take my word for it that this is actually real data, but we can check it if we pull up a visual diff, right? So we can paste the response there and go and execute a search against the raw data. So here we've got the metric beat index, and we use the regular search endpoint with the same query. We can execute that, take that response. And you can see that the responses are, in fact, identical. So even though we're using this much, much smaller index, we can use the exact same query and get the same results. Now, I don't really have time to show you all the cool things that we can do with rollups, but suffice to say, there's a lot more flexibility here than what you'd normally expect from a rollup system. So this much more complicated aggregation here, we've got a date histogram on daily intervals instead of the hourly interval before. We've got 2 different terms aggregations that are embedded inside each other, and then 3 different metrics at the bottom. And when you execute it, it runs exactly as you'd expect from a regular search. And what's interesting is that it's all being generated from this small rolled index. And a nice feature of this is now you have your rolled up representation, which you can use to accelerate dashboards, and you still have your raw data, which you can keep around for more fine-grained analysis. And at some point, if you decide you don't need your fine-grained information anymore, you can go ahead and deprecate out that data. So that's the roll-up feature. If you have any questions or this interests you, I'll be at the AMA desk pretty much all conference, so just come find me and chat. Thanks.
Thank you, Zach. So I imagine that due to these features, Zach will literally be in the AMA desk for the whole conference, explaining how it works. But this is pretty impressive. You still need to choose which dimensions you want to roll the data on, but what we've tried to enable you to still have all the flexibility that you want to have when it comes to executing as complicated or as advanced search requests that you want over this data. I'm super excited about this. This is a feature that will first roll into Elasticsearch hopefully in one of the next minor versions. And then we will make sure that Cabana gets upgraded and enabled to be able to use this feature. And we're obviously going to try to make it as seamless as possible, the transition from raw data to roll-up data. So that's one core feature that we consider to be, and I hope that you can see how this can apply for many different use cases. Another feature that we've been working on for some time, our machine learning feature. So we've joined forces with a company called Alert from London almost 2 years ago now. The company has built an amazing anomaly detection engine. And we've taken that and we've integrated it into our stack. It's now just a part or a feature of our stack. The team, and we've called this team, and we've called this feature machine learning, even though machine learning is such a huge topic. But the idea is we try to convey to you, our users, that we want to go more, and we want to go way beyond just anomaly detection. And our goal is to slowly start to address other aspects in the machine learning space that is admittedly extremely huge. And one of the things that we've done, and it's one of the obvious one I would say that we would want to do, is that once we can look back in time and detect anomalies, and based on the models that we've built as a result of it, maybe we can use that model to look into the future and try to forecast what's going on in a system. For example, is a disk going to run out of space in one of your data centers? Is a certain KPI going to start to trend up and to the right or down and to the left, which is tricky to do with time-based data. And in order to see what we've done over the past year, I'd like to welcome Steve Dotson on stage. Steve?
Great, thanks. Hi, yeah, I'm Steve, and I'm the tech lead of the machine learning group. And what I'd like to do is do a very quick demo of the machine learning features in the Elastic Stack. So to start with, the data here I'm going to analyze is the New York taxi data. And as you see, that each record here represents a taxi trip. So it has the pickup and drop-off location, the total distance, the cost and so on. And what we'd like to do is to analyze this data to try and use the machine learning capabilities to try and get some insight out of the data. So, so if I go to the machine learning tab and click on this, what I can do is I can create a job. And what we're doing when we're creating a job is effectively taking some data that's stored in Elasticsearch and pushing it through the machine learning components which are part of the XPack plugin. And that's creating models, identifying anomalies, and I'll also be showing some examples of forecasting using the same technology later on as well. So I'm going to start with the New York data. And I'm just going to initially just perform a very simple job here, which is going to be looking at the overall rate of pickups. Okay, and I'm going to put this in a particular group, and I'll explain while I'm doing that in a minute. Oops, I missed off the group there. I'll show you the demo anyway. So effectively, what we have here is the data analyzed, and back here we see that there's an anomaly in the data. And this anomaly here is actually on the 14th of March. And if you look at what happened in New York on the 14th of March, there was a low volume of traffic there because there was a lot of snow on the roads, and so there was a lot less taxis being picked up there. There's another feature that I was going to demo. I didn't put job groups in there, which is talking about scheduled events, which allows us to actually treat certain events differently. So here, there's actually a daylight savings time, and we can treat that differently to the rest of the data. And that's something that we'll be demoing on Thursday when we have a bigger session. So now on to forecasting. So I've done the sort of the basic anomaly detection that we demoed last year, but now I'd like to show, well, let's forecast and actually predict sort of where these values are going to go potentially in the next week or the next couple of weeks. So in terms of a use case here, we're going to look at duration of travel. So using this data, we can say, well, using the historical data, can we create some sort of baseline in terms of what the typical times between going from Midtown to JFK are, and then look at that on a sort of a day-to-day basis and an hour-to-hour basis and predict typically how long that travel time would be. Now, we're obviously, we're not building a route planning app here, and then when you're doing something with route planning and you're accounting for traffic and adding weights to the roads and so on, that's obviously a separate problem here. But hopefully I should be able to show you that just looking at the historical data and using that to baseline our predictions, gives us pretty good results. So I'm going to go just to the Midtown to airport journeys, and in this case, I'm going to look at the average duration. And I'm going to run this not to the end of the data, but for 2 weeks before the end of the data, and you'll see why I'm doing that shortly. I'll put this into the job group. Okay, And again, I'm running this, and there's 30 million records running on my laptop here, and we're aggregating the results. We're pushing that through the machine learning components. We're calculating the probability of the current behavior based on what we've seen historically, and and we're updating the models in an online sense as the data is being streamed through. Now, when I view the results, there's a forecast button here, and we added this to the 6.1 in the product back in January. And what I can do is I can use this to forecast where in the next 2 weeks is this signal likely to go. You'll see that despite the sort of data being reasonably sparse here, we can actually create a reasonable baseline of where the data is going to go on a sort of a daily basis. And as Shai said, this is really the main use cases for this are more in the operations environment where we're looking for trends in terms of, is your disk going to run out? Are you going to run out of resource on your machines, etc.? Or what capacity will I need in the next couple of weeks based on the current behavior? But a question is, well, how good is the prediction we've made there? How good is it going to be? If the data keeps running through there, how good is it? And can we compare it to other methods in terms of evaluating its effectiveness? So what I can do is I can go back to the job, and I can actually just run the job for the last 2 weeks of data, and then I can compare the forecast to those 2 weeks of data. Okay, so here's the forecast, which is sort of the greeny line. I'm colorblind, so it's a bit difficult for me to say, but it's sort of the one that's not blue, the smoother one, and then the green one is the blue. Well, hopefully you get the idea that actually the prediction looks reasonable there, and as you can see, we'll be talking about this more, and there's actually a special sort of math session on what we're doing behind here. You can see that the variance in terms of our bounds are growing as as our predictions become less certain moving forward in time. So. The other thing we can do is compare this to things like Google Maps and Bing, because obviously they're specific route planning things. And here I actually sort of ran our data against Google Maps and Bing here as well. And you can sort of overlay the whole lot together here, and it actually looks pretty reasonable. I mean, obviously, in terms of doing this real time with real events and so on, and traffic situations, this is not necessarily the best route planning thing, but you can see here that actually our predictions are pretty much in line with the actual data, and in particular sort of Google's forecasts, which seem pretty good. So when we were going through this, we were thinking, okay, what use cases can we use this for? What New York taxi things can we think about? And I think one of the classic New York taxi journeys is Die Hard 3. Die Hard with a Vengeance, when Bruce Willis and Samuel L. Jackson have to get from 72nd and Main, sorry, 72nd and Broadway to Wall Street, and they're set a time by Jeremy Irons, who's playing Simon Gruber, the evil arch-villain, and he sets them a time of 30 minutes. And so sort of the question is like, is that a reasonable time? Is that like, if you were the arch-villain, would you set that time? Would I set 20, 30, 40? Like, what is reasonable? The good thing is, with XPack and ML, you can actually work that out. And so what we're doing here is doing actually a very similar analysis where we can go. I'll just go back to the jobs, and I pre-ran this just because it's a short demo. And we can see here, here's our predictions for that particular set of journeys. And again, we've got this sparse data going into a smooth line, and sort of overlaying this on the actual data, and the Google data. Here's sort of the results. Now, when we did this, we thought, well, the challenge is actually, well, we knew it was 9:50 because the film makes it very clear that it's 9:50 in the morning that they start the journey. But we didn't know the month, and we didn't know the day, and that obviously affects the things because weekends behave differently from normal days. So after watching the film several times and reading the screenplay, we found out that it was set in July, and there's a very quick glimpse of a calendar clock as Samuel L. Jackson enters Wall Street that says Tuesday. So Tuesday at 9:50, we have this time here, and the red dot is Simon's predicted times, and the others are the predictions from Google and ourselves. And it's actually, not that far off. So I think, it's not. You can see it's actually not that similar from just a standard travel time. So Bruce Willis going across Central Park, tailgating an ambulance, maybe wasn't really required to get there in that time. So there's going to be plenty more. There's plenty more. As Shai said, we're looking outside of time series and we're doing other analysis as well. And on Thursday at 11:30, myself and Sophie will be going into a lot more detail. But it'd be really great to get your feedback and to hear your experiences with the product this week. Okay.
Thank you very much, Steve. Yeah, so in that movie, I think Simon says, not for all your gold in your Fort Knox. And they end up stealing large portions of gold. I would say that if this movie would have done today, they would end up having a trucks full of hard drives filled with Bitcoins. Which leads me to say, try to run our forecasting tool with the Bitcoin price, but I'm not guaranteeing anything around your ability to be successful with it. Okay, from machine learning, another feature, or a few features that we introduced yesterday. But first, let's talk a bit about dashboarding. So for a long time, we truly believe about the data that exists in Elasticsearch and what you can do with it. But we also believe about reaching the user as far as possible. And part of it is actually being able to go and create visualizations that represent the data. And those visualizations have been done mainly through Cabana, but you've been building your applications and visualizing data on top of Elasticsearch for a long time. But dashboarding was the one that we had out of the box. And dashboards are great. They're great for operational data. They take raw data and represent it the best way possible for people that end up operating various types of data sets. But we started to see these dashboards pop up in other places, not only in the operational use cases. And to be honest, when we look at them, we said, it's great, but we think they can be nicer, and we think that they can be more beautiful. So we've introduced Canvas last year as an effort that we have around being able to create another tool alongside dashboards that allow you to go and try to express yourself on top of data that exists in Elasticsearch in a more free-form manner. And when you try to do that, you also want to have a language that is easier to use and easier to explore when it comes to exploring data in Elasticsearch. We love our APIs. We love the query DSL. But obviously, SQL, as an example, is a very approachable language that you can go and use. And we've also talked about SQL as an engine on top of Elasticsearch last year. We've been working really hard last year to try to bring these two features to fruition. In a nutshell, it means taking these dashboards and trying to move it into something like this, which is more expressive, same data, tend to be same data, but more expressive, something that you'll be proud to put not necessarily only on an operational NOC, but also at your CEO office. And in order to show you where we are at when it comes to both Canvas and SQL, I'd like to welcome Rashid on stage. Rashid?
Good. Hey, all right. Thank you, Shai. So like Shai said, last year I got the privilege to introduce you to Canvas. And this year I get to show you all how Canvas works, really show you the nitty-gritty of how it operates tomorrow. Today I've only got about 5 minutes. So instead of showing you how it works, I want to show you what we've got coming up. And like Shai said, we've started to integrate it with SQL, which means we can do some really neat stuff like create charts and graphs with one-liners using nothing but SQL. So if you're interested in what's on the screen right now, this is actually from a slot car track that we have set up at Elasticon that we're streaming the data into Elasticsearch from. So we're going to look at a little bit of the data from that, but instead of looking at this page, I want to move on to the next page. So I'm going to go ahead and disable my auto refresh here, and I'm going to pop over to this page that is much more boring. So all we've got right now is a blue dot in the middle there. So I'm going to click on this, and I'm going to open up my little SQL editor here. So right now, we're really not selecting much at all. But because this is SQL, we can do things like this. So we can do, say, select driver as Y referring to the Y axis, and we'll do a group by driver. All right. There we go. Okay, so we got our list of drivers, not at all in alphabetical order, but of course this is Elasticsearch, so we can still sort. So let's order by driver. All right, so we've got everybody in alphabetical order now. But let's add something more useful than just a static row of dots here. Let's do, let's say average time as X, and let's also do max of speed. So the highest speed that I attain on my way around the track as size. Okay, let's try that. Okay, cool. So now I've got this list of how fast everybody's making it around the track on the x-axis, and then how fast they're going at what their max speed was as the size of the dot. And I mean, we're seeing some pretty obvious trends here. The faster you go, chances are the faster you're going to make it around the track. But one of the things that I really love about SQL is that, well, a table's a table. So whether you're doing aggregations, right now that's what we're doing under the covers here, right? We're using average and we're using max, and the group by is just running a terms aggregation right now. But again, in SQL, table's just a table. So we don't have to do any of that. We can really get an idea of where the majority of races are coming in. Instead of just looking at roll-ups, we can look at raw documents. So let's change some stuff up here. Let's get rid of this group by and the order by. And you know what? Let's just get rid of driver altogether. So instead, let's do speed as Y, and we'll leave time across the x-axis. And, let's leave speed as size still. Anyway, all right, so no more group bys. There we go. Okay, cool. So now we've got a whole bunch of documents spread out across, and we can see that for the most part, there is kind of like a fat middle to this where a lot of people come in there, like kind of right around here. But there's also that really awesome big dot way up there in the corner. It was that rare intersection where somebody managed to go around the track incredibly quickly, but also hit a very, very high speed. Although technically there was somebody that managed to do it in a smoother way. That is, they didn't hit as high of a speed, but they also didn't have to brake as suddenly. They maintained a better exit speed than that one that hit the highest speed. So you really have to find that nice balance. And that's kind of what we shoot for here at Elastic. We try to find that amazing balance between operating really, really smoothly and also being really, really fast. So good luck at the slot car track. I really hope that you end up being the dot in the upper left there. All right, back to you, Shai.
Thank you very much, Rashid. So this is extremely exciting to me. First of all, I think it's important to say that we view these features, both SQL and Canvas, as core features of our stack. This is something that you can take and put any type of data to be able to go and visualize it in a way that it probably goes way beyond just dashboarding. I will also mention that Canvas is much more than just being a front end for SQL. It has a whole AST engine behind the scenes. A lot of thought that went into trying to figure out how do you merge the ability to go and build beautiful visualization together with the expressibility of data sets. Tons of it that we're slowly rolling it out. Canvas, by the way, is already in basically a public beta as a plugin to Cabana, and we're going to roll it into Cabana in the next minor version. So that's a bit about Canvas, and that's a bit about the three features that we ended up choosing to show and talk about when it comes as a generic features when it comes to our stack. One of the things that I've talked about is the fact that you take our software, take our products, and end up using it for your own use case. And what we've been doing a lot in the past couple of years is not only focus on generic features that we think that will enable you to go and build your own solutions or solve your own problems and also try to solve unexpected ones. but also try to take common ones that you try to do every day and make your life simpler as a user. Being able to go and download the products and being able to tail a log file as quickly as possible. Being able to go and download our product and being able to go and monitor a system within a few seconds. That's something that we've shown over the past year. And obviously, this is a lot of work that goes into not only being able to build a stack, but also going deep, as we say, within a specific solution. And I'd like to start to cover a few of the things that we've done over the past year. I think the first one is obviously logging and metrics. Those are extremely popular solutions for us. And we don't stay stale with logging and metrics. I mean, the environment changes every day. When it comes to try to capture log files and we try to capture metrics. So the best example is that now, if you're using services like, or tools like Docker and Kubernetes, if you're re-architecting your service, your system, to have many more services that are single purpose versus one service that is multi-purpose, you end up in a system that has services coming and going like crazy. And you want to be able to have a system or a way to monitor those applications in an efficient way, and hopefully in a way that you don't have to go and try to change configuration files every day. So we've really embraced that and embraced this new way of building applications. And we've done a lot when it comes to being able to auto-discover various services that are running in common platform, or whether it comes into trying to be able to monitor or tail log files that come from systems like Docker and Kubernetes. And in order to show you what we've done over the past year, I'd love to welcome Monica on stage to talk about it. Hey, Monica.
Thanks, Shai. Hi, everyone. So, a critical feature for any monitoring solution for Kubernetes is to be able to dynamically adjust its configuration when something happens in your cluster. Because you don't want to change the configuration of the monitoring solution each time a new pod or a new application is deployed in Kubernetes. In Beats, this is solved by the auto-discovery feature. And to demonstrate the auto-discovery feature, I would like to show you this new Cabana app that we have been working recently. It's still work in progress. It's called Infra UI. And this is a great way for you to see an overview of your infrastructure of your running services. So if we go to the Kubernetes tab, here we'll be able to see all the pods. And each of these boxes is a pod. And you can group them by different fields. For example, you can group them by container name, namespace, node, and so on. And also, you can filter them to select only a few pods by the same criteria. If we click on one of these pods, we'll be able to see this dedicated, curated dashboard that gives you an overview of your pod. And it gives you metrics like CPU usage, memory usage, network traffic, and so on. Metrics that are collected with Metricbit, but also logs. Logs that are coming from that particular pod that are collected with FileBit. Now I would like to show you a simple deployment that I did. It's a deployment for Nginx. And for that, I will need to set the filter to Nginx deploy. And then, as you can see, I have here 2 Nginx pods that are running on 2 different nodes. Now let's scale my deployment to 5 Nginx pods. And for that, I'm going to use the kubectl scale command, where I set the replicas to 5. It takes a bit of time for Kubernetes to create all these new pods. So now if we go back to the UI, we'll be able to see in a second. Yeah, here we are. So we have 5 pods. So it's cool to see that how these pods show up in real time in this UI. But this is not sufficient for monitoring Kubernetes. Besides seeing a list of all your pods, you also want to monitor the service that is running in each of these pods. And in our example, Nginx. And for that, you have to run the Nginx module for metric bit to collect the metrics from Nginx. You also have to run the Nginx module in FileBit to collect and also parse the Nginx logs. OK, now, in bit 601 is coming with this manifest files that we are using for deploying metric bit and file bit. That makes it easier for you to deploy metric bit and file bit on your Kubernetes. And here, basically, this is the metric bit manifest file. And here, what I did, I added this section to configure auto-discovery. And here, I instruct metric bit to start to listen for Kubernetes events. And when a new pod with the container name Nginx starts, then it enables the Nginx module to be able to monitor the Nginx service inside that new pod. And here, as you can see, I'm setting this config template to configure the Nginx module. And here, under the host, is basically is constructed the URL of the Nginx service based on the properties of the pod. Similar, we are doing this for FileBit as well. And here, I'm configuring auto-discovery. And when a new pod with container name Nginx is started, then the Nginx module in FileBit is started to be able to collect and parse the Nginx logs. So now if we go to, if we start this, then we'll be able to see this under this dashboard that I prepared. So this is a dashboard that shows you an overview of the Nginx dashboard, of the Nginx service. And as you can see here, I have 5 pods. So it knows about my pods. And also, I can see the logs that are collected from all these Nginx instances. And as you can see here, I have the Nginx error logs, and I also have the access logs. And as you can see here, the access logs are already parsed. This is because of the ingest pipeline from the Nginx module in FileBit. Now let's go also to metrics bit overview. And here you will see the aggregated metrics that are coming from all these Nginx instances. And you can see things like active connections, request rate, drops rate that are coming from all these Nginx instances. Or we can select an Nginx host, and then we'll be able to see all these metrics that are for this specific Nginx host. That's all. Now back to Shai.
Thank you very much, Monica. So I hope you can see how we keep on challenging ourselves, to be honest, to try to figure out how we keep current with the level of technology that is going now, and making sure that when we talk about loggings and metrics, it's not only how logging and metrics were used to be captured a year ago or 2 years ago, but how they're going to be captured in a year or two. I'm also very proud that I managed to pass through this whole session without saying microservices. So mission accomplished so far. When you think about typical data streams for monitoring applications or running an operational system around applications that end up being deployed, logs are a very common data source. They're relatively passive. Application spews out logs based on whatever a developer decided to write and end up capturing data and being able to monitor it. Metrics are another relatively passive system. There's APIs that systems expose, whether it's Nginx or something else, and you end up pinging them and being able to get their health. But there's another data set that is as valuable as the other two. And this data set we started to see happening basically thanks to you, the community, as it grew and grew. And we started to see APM-type data starting to be stored in Elasticsearch. I think one of the best examples that I can say is an open source project like OpenZipkin, for example. One of the most popular outputs for it was Elasticsearch. And we really took notice, and we started to say, okay, it's really interesting what's going on. We're working really hard to make Elasticsearch a great engine, not only for text or for unstructured data, but also for numbers, for many different reasons that we've talked historically about. Then maybe APM is a natural place for us to go to. Almost 8 or 9 months ago, we've joined forces with a company in Copenhagen called Audited. Audited has developed a SaaS service for APM. We were very excited about what the team has done, especially partially the use of our technology to be able to achieve some of the operational aspects of running it. And over the past few months, we've worked pretty hard in terms of taking all of that technology and making it a feature in our stack that you can go and download and run yourself. This feature has GA'd about a month ago or a few weeks ago. And I'd love to show you where we stand when it comes to APM data in the Elastic Stack. For that, I'd like to welcome Ron on stage. Ron?
Thanks, Shai. Hello, everyone. My name is Ron Cohen, and I'm the tech lead for the APM group at Elastic. And I'm extremely excited to be here today to show you what APM on the Elastic Stack looks like. As Shai mentioned, it became generally available with version 6.2 of the Elastic Stack, which got released just this month. When you open up Cabana, you'll see this sweet new APM tab on the left side. And when you press it, we'll immediately show you how to get started instructions right in Cabana. And the way it works is you have these APM agents that you install into your application, just like you would install any other package or module or dependency. And they instrument your application automatically in order to give you this very rich application-level performance information that helps you debug your applications. The APM agents talk to an APM server that you run centrally. And that puts the data into Elasticsearch, and you can then consume it using this UI that I'm going to show you in a second. OK, so let's actually try to set it up. So you download and install the APM server, and then you run it. So let's try and do that. Here we go. APM server running locally on my machine. Yep. The next thing I need to do is I need to install an APM agent into my application. And let's try it with a Node.js application that I have here locally. So all I need to do is install the Elastic APM Node module, like this. There we go. And then I need to put in a few lines of code that's going to configure my the module that I just installed, like so. Because I have the APM server running local on my local host here on a laptop, I don't really need that. But this stuff, here I put in a service name. So I just give the service a name. Let's call it up beans node, like this. Then I just need to redeploy my application. And we should see data starts to stream into the UI. Here we go. Now, I should probably mention that getting this automatic instrumentation right is actually very, very tricky. And so we worked really hard to make it this simple. All right, let's see if the data is coming in. Yep. So here I see the application that I just set up. I can dig into it here. So here I see 3 different tabs. The first tab shows me information about incoming requests to my application. So that's web requests. The second tab will show me any background jobs that run in my application. And the third tab shows errors that are collected in my application. So we also automatically collect errors that happen. So right out of the box, we give you response times. We show you the average, the 95th percentile and 99th percentile response times. We show you how many requests per minute your application is serving, split into the different HTTP status codes. So you got your 200s, 300s, 400s, and 500s here. And then we have this table of the endpoints in your application. Now, for each endpoint, we can show you the average response time, the 95th percentile, and how many requests per minute that particular endpoint is serving. We can dig into it. And here I have the same 2 graphs, but just filtered down for this particular endpoint. And then here I have a response time distribution graph. Now, this graph is useful in order for you to see what the distribution of your response times is. What typically happens is you have a bunch of requests that are served really quickly, and then you have this long tail of requests that take longer to serve. And the idea here is that I can press these different buckets, and I'll get a sample from that particular bucket. So a sample for which the response time fell within that bucket that I selected. So let's pick a slow one, that one, for example. So looking at the sample, I can see the URL that was requested. I can see the result. I can see the timeline here, which is really interesting because the timeline shows me what my application was doing trying to respond to that incoming request. The orange here is SQL queries, but we'll also show you any templates that got rendered, any cache calls, any calls to external services that happened during the call to this particular endpoint. And it looks like the sheer number of SQL queries is what's slowing down this particular. The good thing is I can open up and get more information about what's actually going on. So each individual SQL query only takes about 8 milliseconds here, but because there's so many of them, it just adds up. You can see the actual SQL query that was executed, and you can see a stack trace from where in your code this particular SQL query was executed. And that makes it really easy for you now to go in and start optimizing. So clearly there's some SQL query in a loop here somewhere that I need to go and fix. I could dig into more information about this particular sample, like which server responded, information about the process, but I can also see the user that requested this particular request. And if I want to, I can tag individual transactions, for example, with the customer ID or something similar. That makes it very easy for me to go in and find particular samples for particular users. Now is a good time to remind you that this is all really just, oh wait, hold on, that's not what it is. This is all just documents in Elasticsearch. And the UI that we're looking at is really just showing you documents in Elasticsearch. There you go. So you see, if you want, you can always dig into the actual data in the Discover tab. And that also means you can create your own dashboards. You can start to correlate with other types of data. I also wanted to show you the errors. So because we get this very rich performance data from your application, we get really rich information about errors that happen as well. And what we do is we group errors together. So different instances of the same error gets grouped together. And we sort them by in which group the most recent occurrence happened. And this makes it very easy for you to get a good overview of what the errors are that are happening in your application. I can dig into a particular error here. I can see the message, the error message. I can see the occurrence, the frequency of this particular error. And here's a particular occurrence of the error. And I get a really nice stack trace that shows me the actual code that was executed. I get more information, just like you saw before, about the process and the service. And again, I can put user information in, so I can see which users experienced this particular error. And I can tag the different transactions so that I can see the customers, for example, that experience particular errors. That's it. Thank you.
Thank you very much, Ron. So I admit, almost on a similar matter where I had this, personally I had this deep belief that search can apply for many different use cases. And to be honest, like logging was just a surprise, but a pleasant surprise. I admit that I've never imagined that APM data will find itself being stored in Elasticsearch and Apache Lucene. And it just makes sense after you see all of the other types of data that are being stored there and the flexibility that search as a system can give you. And at the end of the day, it also speaks very highly into all the progress that our teams and the community has done when it comes to improving our products to live up to the expectations that you have. Ron mentioned towards the end the fact that one of the most powerful aspects and why this even, I believe, happens in the first place is just the ability to put data in the same place and then being able to correlate it and try to understand more about what's going on in your system. At the end of the day, we like to say it's just another index in Elasticsearch. And whether that index is logs or whether that index is a metric or monitoring index or whether that index is APM, you can now take all of these three indexes and make interesting realization as a result of them. And in order to show you just a tip of what's possible if you take all of this data and put it together, logs, metrics, or monitoring, and APM, I'd like to welcome Tanya on stage. Tanya? Go.
Thanks, Shai. I've got a long walk here. All right, so this demo scenario should be familiar to many of you just based on your experience shopping on the internet. You can look for an item on the site. You can examine it, decide that you want it, add it to a cart, and hopefully purchase it. The infrastructure underlying the site is also based on fairly common components. You'll recognize Django for application servers, Apache and Nginx for proxies, MySQL for a database, and of course, Elasticsearch for site search. From a monitoring perspective, we're doing exactly what Shai just mentioned. We're bringing together all these historically disparate sources of operational data into a single instance of Elasticsearch dedicated to monitoring this site. So we're taking the Elastic APM Python agent, and that's running within Django, looking at things like durations of operations within the application server and errors. We're taking metric beat and packet beat, something that Monica talked about earlier, to look at infrastructure metrics. And finally, file beat and audit beat add log information and other event data to help us with root cause analysis on top of all of these KPIs. We, of course, have Cabana sitting on top of it, and we have machine learning and alerting running on all of this data holistically to give us a view into all of the anomalies that we detect on top of what's happening within this site. As an operator of this site, one of the things I'm really concerned with is abandon rate. So this is when users place something in a cart, but then don't purchase it. And of course, that's going to happen. Some users will change their mind. But what you don't want to see is a sudden spike in abandon rates that's unusual for the time of day of week. Usually that indicates that a site is not performing well and is preventing users from buying your products, from having a good experience. So of course, I'm very concerned when I see at the top of my inbox exactly that, a high abandon rate anomaly detected by a machine learning job looking at that specific KPI. Looking at this machine learning job, the silver lining is at least we detected this right when it started crossing an important anomaly threshold. So let's go ahead and troubleshoot this. This is a Cabana dashboard that starts at the business level view. So I'm using transactional data that's recorded from the application straight into Elasticsearch to look at various business level KPIs, including above mentioned abandon rate. And here's my most recent spike. And here's this blue line, which is inching toward the top, not something you want to be your business trend. Looking below, I actually noticed that my sales are also affected. So this is not something that's a red herring. This is something that's immediately affecting my business. I need to investigate as soon as possible. What's really cool about this dashboard is, in addition to the business KPIs, we can weave in APM data that's most critical to this view. In this particular case, I want to see any user-facing errors on the site right next to all these indicators to see kind of the first level of potential root cause. And in this case, indeed, there's a cluster of errors happening right now. So what we'll do is we'll jump to investigate to see if that's relevant to what we're looking at. This is the APM UI that Ron just showed you. And I'm not going to go through this in detail, but I'll just look at the errors in particular. And there are a few of them that are possibly innocuous, but this checkout internal server error looks really bad. And if you're a developer, you'll notice this is a number parse exception on a phone number validation procedure. Thankfully, it's probably very easy to fix. We just need to do that immediately, because clearly this is not allowing users to purchase items from our site. Now, I wish I was done, but nothing in operations is that easy, as you probably know. If you look back at some of the previous spikes that didn't trigger the machine learning job, because maybe the average rate wasn't as high, those look pretty concerning as well. And those happened way before the errors started clustering together. So possibly there's something else happening on the site as well that we should investigate. As you probably know, another problem that's commonly felt by users on sites where they walk away is slowness. If a site doesn't load or partially loads, most of you will probably just say, never mind, I'm going to go somewhere else. So again, as an operator of the site, I'm, again, very concerned to see site performance anomalies found in this data set. And those go way back. So let me start with the one that's the earliest. And again, this was detected by a machine learning job. I'm going to go ahead and take a look at that. And the first thing I note in this view is that the slowness is not pertaining to a particular part of our site. This is actually spread across several important views, such as basket view, order complete view, default checkout, all of important views, but not just one particular page. So when I see that as an operator, I typically suspect an infrastructure problem. So that's what I'll look first. I'll look at my infrastructure analysis dashboard. Again, this is a Cabana dashboard. Everything in here is just based on another index in Elasticsearch. But it's bringing all of the data together to help me troubleshoot this scenario. We see site response times from APM. We see things like memory usage, CPU usage, and total disk I/O from MetricBeat, network data from PacketBeat, and finally, slow logs from MySQL and AuditBeat data. So let's go ahead and take a look first at site response times. That's where we'll start kind of with the user experience. We see that this started on January 20th, and if I just take a look at the time frame when this began, a couple of things I note. First of all, this memory profile doesn't look great. That's very concerning to see the memory consumption on my database just sort of go up in an unbounded manner. But these CPU spikes also look very strange, very irregular, and something that I'll just investigate first, given that they are very obviously strange and across the whole infrastructure. Zooming in on one of those spikes, I can see that there's a lot of traffic going between the MySQL database underlying the site and something called proxy01, which I know is my internal proxy. I don't expect that to happen. I don't expect that much traffic happening between an internal proxy and my database. So let's go ahead and take a look just at that proxy. And a curious thing pops up. So we see AuditBeat, which is one of the metrics that it looks at, is unusual processes, so processes that were started on all of our hosts. And something called reported.py jumps to the top of that list. Let's take a look. Right? That sounds like some sort of reporting job. Again, I don't expect that to be happening. And if I can only click in the right place, we can see that this job indeed is happening very regularly. If we look closer, we see that it's happening every minute. Now, I think that's suspicious, but if it's, if there's a business need to do that, we need to move that off our production database. That's definitely not something that this site was designed to do from a load perspective. We see if we kind of go back and zoom out back to a wider time interval that this kind of load is causing a lot of problems on the database itself, very slow select statements across the whole site. So we need to isolate this process to some other place. So in summary, this demo really highlights how elegantly and simply Elasticsearch brings together these historically separate sources of data that are very important operations: APM, infrastructure metrics, and logs. And when I speak to users, part of my job, many of you have already embraced that, and you've put logs and metrics into Elasticsearch, and you're looking forward to adding APM to that scenario. But for some of you, I find that in your environments, historically, you've relied on separate tools for these jobs. They're hyper-focused on one use case, and that's nice, but the thing that many of you miss is this ability to bring the data together to tell a story. Some of you actually have built custom UIs to do that, and that's very expensive. And many of you can't really afford to do that, so what ends up happening is these troubleshooting scenarios that really should take minutes, maybe hours, take days or even weeks. While basically the business is bleeding money. So my hope is that this demo inspires you to take a look at your operational intelligence and think whether Elastic can help you there. And hopefully we can focus on making operations more efficient while you focus on running your business. Thank you very much.
Thank you very much, Tanya. I love this demo because it basically proved the fact that every operational problem either boils down to date parsing or a misconfigured cron job. So this is proof. Another thing that happened over the past year or two is the fact that we started to be used quite a bit in the context of the security space, which we're very excited about. To be honest, it's a very natural progression out of the logging space, especially with an area that is called SIEM. If you capture enough logs, enough metrics, enough information about your infrastructure, you can actually make interesting decisions that apply to the security space, the other side of the house, of the operational space. And we were very happy almost a year ago when we got an email from the team at Mr. Robot, the TV show, and they asked for permission to use Cabana in one of the episodes. So obviously we were all very giddy and immediately forwarded to all at Elastic and started to celebrate. And then we saw the screenshot, and we saw that Mr. Robot was using an old version of Cabana in our stack. And we said, we think the product looks slightly better now. Can you please use a new version of the product? And the team said no. And we're like, another user that struggles with upgrading to a new version of our product. Can we get a break? And we asked them why. And actually, we were impressed. We've read a bit about it, but the team tries to be extremely authentic around the tools that they use that match to the time frame. And specifically, this episode happened in a time frame that ran that specific version of Cabana. And that level of authenticity ends up spreading all over the show and to the level of the technology that is being used. And every single thing that happened in the show has real-world products and use cases and thought that goes into it. So we're very excited to try to explain a bit how Elliot uses Cabana to fight the dark army. And for that, I'd like to welcome Ryan on stage. Ryan? Thanks, man.
Thank you, Shai. Hi, everybody. My name is Ryan Kazantsian. I'm a technical consultant on Mr. Robot, as well as chief security architect for Tanium. As technical consultant for the show, my job was to weave accurate depictions of technology, of hacking, and computer security throughout the show's narrative. As a practitioner in the security space, this afforded me a really cool opportunity to include the software and tools that I've used throughout my career. And I was especially excited to have the opportunity to weave in Elastic, especially given the fantastic community that's behind it. What I'd like to do tonight is walk you through a little bit of a behind-the-scenes look at the hack that bridges through the first half of Season 3 and culminates with the inclusion of Elastic at a critical juncture in the story. So as many of you probably know, the storyline in Mr. Robot revolves around a fictitious super company called Evil Corp, or E-Corp. And this is like the conglomerate to end all conglomerates, and it's subject to a really destructive hack in the first season. And at the end of season 2, the storyline revolves around this paper records facility, which is the last bastion of hope for them to recover their data through old-fashioned paper records that they're consolidating. And the Dark Army is trying to destroy this building by infecting a power management system that they've got a backdoor on, and then using it to deliver a malicious firmware update to the UPS devices that control the batteries in the server room. And the idea is that you overcharge the batteries, they emit gas, and eventually there's an explosion. And amazingly enough, this actually happened in real life, though due to an accident, not actual malice. If you want an interesting example of a real-world attack like this, look up the Ukrainian power grid hack in 2015. That involved malicious firmware pushed to control devices. So this alone was grounded in reality. Now, when we get to season 3, this doesn't end up happening. Fortunately, Elliot, our protagonist, saves the day, kicks the back door off that system, and the Dark Army is left without access, at least temporarily, to Evil Corp. So what do they do next? Well, Mr. Robot and Tyrell, as agents of the Dark Army, have to figure out a way back in. And so like any good hacker or pen tester, they go and use a tool called Shodan. Shodan is a website that allows you to effectively fingerprint the internet-facing infrastructure passively of an organization. And so it's like a search engine for the data that your websites and other internet sites are just exposing through banners and other scrapable data. And they find that Evil Corp has in their DMZ web servers that are running a unpatched, out-of-date version of Apache. Specifically, they're vulnerable to a Struts exploit. If that sounds familiar, it's because Struts has, unfortunately, a long history of pretty bad vulnerabilities. Most recently was exploited in 2017 to lead to the Equifax hack. The one we're using here is actually from the 2014 timeline. So like many companies, I guess Evil Corp, unfortunately, was not doing a great job of patching. So they use this exploit to get remote code execution on a DMZ server, and then they need to pivot. So they go from the DMZ through some hot points and get to internal hosts that they backdoor. And like any sort of attack that involves post-compromise activity, there's lateral movement, there's reconnaissance, and the trick is figuring out what happens next. Now, fortunately, our protagonist, Elliot, is monitoring all of this, unbeknownst to the Dark Army. And he's doing so with log forwarding, with Tanium, with other security tools that are aggregating all these disparate sources of information into his Elastic stack. Now, Elliot is a security engineer at this point in the story, but this is kind of off-the-book stuff because he is actually allowing them to continue hacking so that he can understand what they're actually after. And so he's using Elastic as his own sort of private stack to monitor all this activity and figure out what the Dark Army's next steps might be. Now, this was actually all built out, like all of our scenes, using real systems and real software. So I'm going to cut from the lower right, which is the on-screen shot, to the mock-up, which is a lot clearer. And actually, this is from my own VM environment when I built this. In the top left panel, we have an executed command history that's coming from forensic telemetry, including Tanium and logs on the endpoints. This is a history of every executed command on the infected systems. On the top right, we have a panel that's showing user activity. On the bottom left, we have some other statistical analysis of process activity. And then over on the right here, we have what catches Elliot's eye in the midpoint of Season 3, an indication that the Dark Army is back on that power management system and had a failed attempt to update the firmware that's controlling the batteries on those devices. And so this sets things in motion. And as Elliot monitors the activity, and the on-screen commands actually play this out if you freeze frame and read them, what he finds is that the Dark Army is actually laterally moving to a new target, the code-signing infrastructure team at Evil Corp. And the reason they're doing this is they're gathering data so that they can stage an attack against the hardware security modules. And this, too, was inspired by a real-world breach case that I worked several years ago. So compromise of Hsms is really bad. That's like catastrophic loss for any company, let alone one like eCorp. And so it makes for a really compelling midpoint to the season, and I won't spoil any further, but this is how that all gets set in motion. Now, you might be wondering, why do we do this? Why do we focus so much on this accuracy when most TV and media depicts hacking like this or like this? And I think my favorite is the infamous NCIS episode where they've got like 4 hands on one keyboard so they can hack faster. So many good movies out there. So anyway, the reason, and I think Corralate, the writer and producer that I worked most closely with, puts it really well, which is that if you have to rely on flashy, ridiculous graphics on a screen to explain the drama or the plot, something's wrong with the writing, something's wrong with the story. You're failing to convey the stakes of the scene. And one of the things that we always try to do on the show is make sure that no matter what your level of technical expertise is, you can watch and understand what's happening. And then if you do understand the technology, you have the added bonus of understanding things at a deeper layer and engaging with the show in a deeper layer. And I think this storytelling approach is something as a security practitioner, I try to stay focused on day to day. And I think technologies like Elastic help us be better storytellers in conveying the impact of critical things like breaches. From an audience engagement standpoint, this helps us in the show quite a bit. One of the cool things that we can do is have interactive ways that the audience can go deeper. So there's an alternate reality game in the show where you can take IP addresses and QR codes, things that flash by on screen for just a second, find them online, solve puzzles, and interact with things like this. So this is a interactive version of the same dashboard that we just showed you earlier. You can actually go to this URL, log in if you have the password, and play with it just like Elliot did. We similarly set one up, and this is the Logstash server that's aggregating the UPS logs. There is a sort of emulated SSH interface on a website where if you type the right commands, you can tail the log that Elliot tails in the episode and see the exact events as if it was a real UPS power management system. So these are really fun ways to engage with an audience in a unique way. One last one is just other ways we can kind of hide Easter eggs. We had a shot of the Dark Army's command and control panel where they're managing all of their infected systems. And if you were to freeze and zoom in, you'd see that their list of victims actually mirrors real-world victims of targeted attacks, including governments and human rights organizations. Lots of ways we can make it real. Of all of the technologies that I incorporated into the show the 3rd season, I think the reaction from you all in the Elastic community was the loudest, and it was really validating and exciting for me to see. When every episode aired, the writers and I basically lurk on Twitter and Reddit, just really anxiously awaiting how people react. So it's great to see that type of feedback. I also incorporated a lot of other hacking and security tools. One that I really find fascinating is Mimikatz, which is one of the most widely used tools for Windows credential attacks. And the author of Mimikatz tweeted not only that he was excited to see it, but also caught an error that I inadvertently included where the arguments, I supplied arguments that are technically not necessary. And my response was, well, even the Dark Army operators screw up sometimes. We had this really elaborate HSM attack. I tried really hard to make it real. I figured hardly anyone works with HSM stuff, so no one's going to notice. No, I was wrong. I got lots of incredibly detailed feedback, picking apart scene by scene from the handful of HSM experts out there. Yeah, it was really fun to see this stuff. And then last, I don't write much code anymore. I did have to write a bit of Python for, and I'm going to try not to spoil much here, something involving crypto. And it's embedded in a file. It shows up on screen really briefly, and someone noticed that there was an inconsistency between the source code for taking user input and what was actually displayed as a prompt on screen when the script ran. And so he called that out to me. Again, this is why it's a labor of love, because people notice those things. Mr. Robot is just my night job, what I did between 10 p.m. and 3 a.m. for the course of just about a year. During my day job, I work for Tanium, and one of the really exciting things is that Tanium is a great engine for data for Elastic. And many of our customers are doing really cool things with our technologies together. For example, automating endpoint vulnerability management at scale, feeding data from 70,000 plus endpoints to create really powerful risk dashboards and to take corrective action. I'll be here throughout the week. I'd love to chat with you about these and other use cases, but I just want to thank you all for having me here. It's humbling to be part of this conference and among such an amazing team and such an amazing community. Thank you all and have a great conference.
Thanks, Sam. Oh, sorry. Well, that's really
exciting for us, this level of use of our technology. I can also say that one of the interesting aspects that I see in the security space, typically the way that our stack gets adopted, it's part of the story of open source, is that it gets adopted from the bottom up, if you will. Developers like yourself download the software, start to use it, try to solve a logging problem or a security problem and start to use it. And try to figure out how it works and whether that can be used. That's the Elliot in the story. But we also see quite a bit of companies now, specifically in the security space, that struggle with large volumes of data and still being able to have this interactiveness aspect that Elastic provides. So companies like Tenium, companies like ArcSight, and others are starting to add support for Elasticsearch in order to be able to push data to Elasticsearch and using Cabana in order to visualize it. So it's not only the tools that we build and Beats and Logstash, but also other systems in the security space are integrating with what we build. And that's pretty amazing to see. To continue with that, and to be honest, to also give you a sense of what you can actually do with our stack when it comes to the security space, and it's a similar story if you'll see also when it comes to our operational logging, I'd like to welcome Asavri on stage to give you a sense of what you can do with our stack when it comes to security. Asavri?
Thank you, Shai. All right, so as you probably gathered from Ryan's talk, detecting real attacker activity in your systems, your infrastructure, is painstaking work. And what we'll show you in today's demo is how the Elastic Stack can be used not just to detect security breaches, but also do that post-detection investigative work to see how the attacker got in, how they moved about your systems. A quick shout out to Justin and John at HNA Security that helped us with this demo. So for the next 8 minutes, I'm going to step into the shoes of a security analyst at LabMe Inc. And what you're seeing on the screen here is a sample of the security monitoring architecture at LabMe. So we have Beats running on all of our endpoint devices, specifically WinLog Beat that's collecting all of the Windows event logs, and Packet Beats that collecting all of the network packets. All of this data flows into Logstash, where it's enriched and parsed. From there, it gets indexed into Elasticsearch. And then we use Cabana as our data exploration and visualization layer for all of our investigative work. Now, I've just received an email in my inbox from a machine learning job that's alerting me to a possible DNS exfiltration attempt to this covertc2.com domain. So let's follow this link to investigate this further. Now, while this job is loading up, what this particular machine learning job is doing is looking for unusually high information content on the subdomain field of my DNS traffic. And this particular red period here contains the anomalies that triggered the alert. So if I zoom in on one of these anomalies, not only is it telling me that this particular anomaly is a severe anomaly based on this normalized severity score, but if I zoom in here, machine learning is also doing influencer analysis to highlight that this host, HR02, and this domain, covertc2.com, contributed to this anomaly in a significant or a meaningful way. In other words, it's highly likely that this DNS exfiltration attempt happened from this host HR02 to this domain, covertc2.com. So it helps me kind of narrow the scope of what my next steps could be. So at this point, what I want to do is say, OK, what else was happening on this particular host, HR02? And to do that, I'm going to switch over to a Cabana dashboard that's set up to look at the Windows log events. Now, this particular dashboard has already been filtered down to the 2 influencers that were detected on that anomaly, right? So covertc2.com and HR02. Now, there's a lot to unpack in this particular dashboard. It's looking at the Windows event logs from a lot of different angles. But as I scroll in, the one thing I want to zoom in on is what were the new processes and services that were started on this particular machine that spoke to this particular domain. And the thing that stands out to me as I'm doing that is a whole bunch of DNS cat calls that were run from the command line. So folks here might know that that's a common utility that's used for DNS tunneling. The other thing I notice here is that all of these commands were run by this one user, W. Grimes. So what I want to do now is see what else was Mr. Grimes up to on this particular host. So let's zoom out here, add wgrimes as another keyword or filter, get rid of my domain here. And again, some interesting signals are starting to pop out, right? I see this kind of high use of netuse command, probably something I want to look into. But as I'm scrolling through, the thing that catches my eye and worries me is that this user, wgrimes, managed to successfully connect to the CEO machine from this HR02 host. And I say, uh-oh, this is not good, right? This is a red flag. So at this point, I want to do is I want to flip over and say, what else is happening on this particular CEO machine that I should possibly be worrying about and take remedial steps for? So I'm going to get rid of my wgrimes user here. And I'm going to change over to look at the CEO host instead of the HR02 host. And when I do that, there are some things that kind of immediately begin to stand out in my timeline plot. I've set this timeline plot to flag interesting events, and there are a bunch of events that are flagged, things like new users that were added or new services that were created. Again, something I need to look into. As I scroll down, I see that in addition to wgrimes connecting successfully to the CEO machine, there was also another successful anonymous login. Now, for the old-time Cabana users in here, or people who use Cabana often, you might not recognize this particular visualization. This was created using a Vega visualization plugin that shipped in Cabana just a couple of weeks ago. Super powerful, super flexible, allows you to create a lot of different custom visualizations. Encourage you guys to check it out. So I kind of keep scrolling through my dashboard, kind of getting some sense of what else is happening on the CEO host. I see a whole bunch of kind of the login activity timeline, again, things I need to look into. And then I notice here that a honey file, security speak for a sensitive or a critical file, was accessed on the CEO host by this wgrimes user. Now, this is probably a miss on our end, probably something that we should have been watching for, and kind of going forward, I'll probably have new rules set up to make sure that I get alerted on honey files being touched. Now, at this point in my investigation, I'll probably take a few remedial steps. I'll take HR02 and CEO, these possibly compromised machines, off my network, do deeper forensic analysis on them, change the credentials on this user wgrimes, and also possibly have a conversation with Mr. Grimes, right? It's highly likely that this is a case of a compromised account, not a case of a bad internal actor, but it's still good to know what Mr. Grimes may have or may not have done that left this vulnerability in the system that got exploited. After doing those things, my next steps in kind of the analysis would be looking at all of the network traffic. Remember, we're collecting all of that packet beat data, and we've set up dashboards to look at all of the network traffic, right? What other things were these two hosts, HR02 and CEO, communicating with in the external world? What ports were being communicated on? So there's a lot of rich things I could explore and investigate further, but we don't want to give all the fun away in this demo. So what I will say is, if you want to see how the rest of the story unfolds, how did the attacker get in, how did they steal the credentials, we do have a full-blown version of this demo running round the clock in the demo showcase rooms both tomorrow and Thursday. So if you're interested in seeing how this plays out, do stop by those demo showcase rooms. So we skipped over a lot of the meaty details in this investigation. But hopefully what the demo showed you is how the Elastic Stack can be used to collect all of these logs and put it in a single place, and then truly engage with them, where you're moving from one thought to the next thought, answering all these questions, and you get answers back at the speed of thought, right? Because as an analyst, that ability to really engage with my data and do it quickly is so important, especially in the security space where time is of essence. And I believe that reason, that ability to really engage with your data, is one of the reasons that Elasticstack is gaining popularity as a security platform for cybersecurity professionals, including the likes of Elliot from Mr. Robot. So do stop by the demo showcase rooms, and back to you, Shai.
Thank you very much, Savri. Mental note, change my password from 123456 to something else. Okay, so we've covered security a bit. Another area that is close to our heart and is being used quite a bit with our stack is geo. So if you think about it, sometimes it's surprising and sometimes it's not, but geo is an extremely popular and useful software in our stack, useful feature in our stack. If you look at it from the application search perspective, you want to be able to go and, for example, filter results, restaurants, based on a bounding box that represents your iPhone or a location or a portion of the map that a user is looking for. So it's heavily being used in search use cases for application filtering based on geo-bounding box or shapes. Geo is also used for ranking. For example, you want to potentially have the distance from your location influence the ranking of results that you display to the user. All of these geo features, as you can imagine, means that we need to invest a lot in Elasticsearch and Apache Lucene to make it a very strong and capable search engine, which we have done over the past few years, started with BKD trees and tons of investment that we've done in this area. If you look at it from an analytics perspective, for example, when it comes to logs, if people are hitting or accessing your website, they have an IP address. You can take that IP address and then create a geolocation lookup on it, and then being able to understand who visits your website from which countries or which location, or potentially in the security space, trying to understand who's trying to hack your website. And this means that you need to be able to take a lot of latitude and longitude type points and being able to go and aggregate them at different levels and being able to display a map of it. There's another type of geo integration that we started to see happening and being requested with us, which is basically start with the map. Start with the map and start to take data that exists in Elasticsearch and start to create layers of investigation on top or understanding on top of that. And we've heard you. I'd like to invite on stage Thomas to show us a preview of an application that we're working on in the GIS space. Thomas?
So hi, everybody. I would like to show you a sneak peek on what we're working on for Geo right now across our stack. So what I'll do here is I'll basically give you a big tour of all the features that we have in the stack right now and how we intend to bring this together into a new UI experience inside Cabana. So what we're looking at right here is actually this map that you see is published by the Elastic Map Service. And the Elastic Map Service is a central service that we host and that publishes basically reference data that you can use. And if you're a user of Cabana, you might have already used it and seen that map right now. What we're working on and want to bring to you soon is the ability to apply styles to this data. So for example, we take our world map layer, and then you can apply a style sheet to it. For example, a dark theme or a more muted theme. And the idea is too that you would be able to author your own styles here too. So let's, for this demo, settle on the dark theme. So our first layer, sort of our context, is our world map, and then I just put on an icon right here where we are right now in the Masonic. So that's our second layer, just sort of to get a sense of where we are right now. And to give you a better sense of this whole layering idea, we'll create a couple maps together right here, all around a central theme. And the theme we'll work on will be the community of Elastic. So the first map that we'll create is a map of basically our worldwide community based on download statistics of our stack. So I have indexed in Elasticsearch all our downloads from our product, so Elasticsearch Cabana, for the last couple of months. And we can look at this as a heat map. And this is nice, and it gives us somewhat of an overview of where our downloads are coming from. But it might not be detailed enough to actually answer very specific questions of which countries has the most traffic. And so maybe this is not the right map that we want to create. What we want to create is actually see this by country. So we'll use our Elastic Map Service to bring in this data. What I forgot to mention earlier too is actually our Elastic Map Service doesn't only serve world map, but you could also bring in, say, satellite data. If you have data that would fit that context. But instead now, actually, let's bring in the world countries, because we want to create a map where we see by country where our downloads are coming from. So let's bring this in. What it's doing right now is we're downloading from the Elastic Map Service this layer and indexing it into Elasticsearch. And why we're doing this will be relevant in the second half of this demo. So here we have, we're looking at our world countries. And now we want to symbolize each country by the number of downloads it generates. So we go in our styler, and what we'll do to attach to this world layer, we are going to calculate the number of downloads per country. And like Shai said, if you use, for example, Logstash, there's a GeoIP plugin that allows you to transform an IP to a lat-long location. So that's what we've done. And that's why we have locations. But the other thing that it does, too, is that it attaches a country code to it. So we can join that to this layer. So our world layer has the ISO abbreviation for a country. And we've indexed each document with this same code. So that allows us to join these two things together. You could do any aggregation, basically, but let's stick with count. So let's do this. And maybe let's look at this already right now. We immediately see that the United States pops out. So the majority of our downloads really was from the United States, and we have about 14 million in the span of about 3 months. It's not that great of a map, so let's adjust our color ramp a little bit to bring out the nuances on the bottom end of our downloads data. So we created a map right now, and actually these kind of maps, so the heat map that you saw, this map, it's already something that you can do in Cabana right now. So for the second half, I thought we'd create a different map, but illustrate the new functionality what we're working on. So what we want to bring into Cabana is full support for the geo-shaped data type in Elasticsearch. And that gives us more power to work with and will allow us to do more advanced functionality. One of the things that we'll be able to do is visualize individual documents. And you kind of already see that with this world map. So each country is a document. And the other thing we'll be able to do is do this kind of analytics on the fly. And so let's do that right now. The second map we'll make is related, but I thought we'd make a map of where we all come from. So I got a data layer, basically the location from all of us where we work. This is anonymous data, don't worry. And there's about 2,500 of us right here. So this is actually custom data, and what I did was imported a GeoJSON file. And the nice thing about GeoJSON is that all the type of geometries that you can store in it are also supported by Elasticsearch. So the indexing step is fairly straightforward. So we'll bring this in, and again, this is now indexing into Elasticsearch. So here is the 2,500 of us. But we have a very similar problem that we had with the download statistics, is that it gives us an overview, but it doesn't actually say anything specific. So what we'll do now is we'll make another world map. So let's reactivate this layer, but symbolize it based on the count of attendees here at Elasticon. So we take this layer, and we're going to count for each country the number of attendees. What we used here, this count actually uses the spatial filtering functionality already in Elasticsearch. So it's very nice to be able to do these kind of aggregations on the fly. So if you look at it, and actually let's hide this for a minute, you kind of have a very similar map as earlier, that the majority of attendees are from the United States. But instead of just playing with the color ramp, because we can do this on the fly, this also means we can refine on the fly. So let's actually bucket our data not only by world country, but also by United States state. So for our reference data, we again go to the Elastic Map service because it has some reference layers that we can use. We bring it in. It's indexing and into Elasticsearch. And we'll style the layer the exact same way that we did earlier. So to each state, you're going to attach a count of the number of attendees here at Elasticon, which we do right here. And we see California jump out. About 450 people are here from California, which makes sense because it's local. We have the same problem again because the nuances at the bottom don't come out. So let's adjust our color ramp once more. And so our map's starting to look like the way we want it. So give a global overview of where we're from and get a sense of which states or which countries send the most people here to Elasticon. Because this is layered, and we have 5 layers on the map right now, it also means that we can sort of individually rearrange and position them as we want. So I think this map would make more sense if we combine the states and the world countries, and maybe move our venue location to the top 2 so it pops out more. And just to get some more detail, we'll add back the attendees, but we'll style them a little smaller so they don't dominate the map as much. The language I'm using here is the Mapbox CSS language. It's a styling language that you can apply to vector data like we do here. So we apply it. And so this is how we created our map of all of us right here. And that was it.
Thank you very much, Thomas. So this is a preview of what we've been working on. It's pretty raw. It's at the same stage that Canvas was about a year ago. But I hope that you can see where we're going for when it comes to really doubling down in this GO or GIS space when it comes to using our stack and using Cabana for. Another area that we've been thinking about when we think about solutions or use cases is actually going back a bit to our beginnings. So when Elasticsearch was released, most of the use cases were relatively straightforward, right? It's like, how do you go and add a search box to your website? How do you go and tend to implement enterprise search? And Elasticsearch is pretty raw. It has very sophisticated and capable set of APIs, but you really need to roll up your sleeve and start to work with it in order to implement these type of use cases. It's been successful, I think, in this space, mostly thanks to the fact of how advanced the technology is. And we've seen over the years how it's being used more and more to power all of these search boxes out there. Wikipedia, for example, is one prominent user of it, or example of it. And, but we still think that we can do quite a bit when it comes to simplifying the experience to go and try to add a search box to your website. Or just implement any type of application search, right? Whether it's a company like Yelp or others when they try to go and implement the application search use case. So a few months ago, we've joined forces with a company called SwiftType. And SwiftType has been around for quite some time. And they basically, the company have seen the delta between something like adding a search box to your website to what Elasticsearch is. And the company has been built on top of Elasticsearch. And within a few seconds, you can go and add a search box to your website. It will go and crawl your website and easily allow you to go and control quite advanced things like ranking and relevancy. It will capture analytics around the queries that are being executed and so on and so forth. This service has been extremely successful and even more so now that we've joined forces with the company, and also it helps a bit that Google Site Search is no longer operational, which is great. But we keep on challenging ourselves because basically what we saw is we saw the Site Search and there's another enterprise search product that is in beta, and there's Elasticsearch, but there's a lot in the middle. And everything that we've built to try to power something like Site Search is actually something that you can go and use yourself. Things, for example, that allows you to easily go and control relevancy and ranking, hopefully using a very simple UI to do it. Or the process of starting with a schema and then having to go and re-index data because you want to remap one field to another or something along those lines. There needs to be tools that help you to do that. The process of capturing every single query that goes into the search engine and being able to store a historic view of it and then being able to analyze and act on it, those are things that you get inside search, but you potentially want to have in any type of application search use case that you would have. So we went back and worked internally, specifically led by the SwiftType team, and we're happy to show you what we ended up with today, which is basically our app search product. And for that, I'd like to welcome Quinn, one of SwiftType founders, to stage. Quinn?
Thank you, Shai. It's great to be here at Elasticon, and I couldn't be more excited to show you what the team has been working on. So all throughout SwiftType's history, as Shai mentioned, we've really focused on taking all the power that you get with Elasticsearch and creating these intuitive ways to build end-user search interfaces, great end-user search interfaces. And so the newest product, App Search, is really focused on the developer working on an application and how can that person have the best experience delivering a search experience to their end users. So what I'm going to do today is I'm going to take you through a demo app that we've built and what it looks like to integrate that app with App Search. So what you see here is the App Search dashboard. You can think of this as essentially the control center for all things related to your search experience. So what we're going to do first is we're going to start from scratch. We're going to create a new engine. Our app's called Food Finder, so we'll just call this, not that, we'll call it Food. So just like that, we've set up the initial parts of the engine. I'm going to take this name, and I'm going to actually jump over to our code. So the app itself is just a simple Rails application. Not a whole lot to it. It's essentially a way of displaying and storing a database of restaurants. So you have the business name, you have the types of food they serve, contact information, and their location. So in here, we have our SwiftType configuration, and you have your API key, things you'd expect like that. I'm going to paste in the engine name that we just created. And I also want to give you an idea of what it looks like to wire up an application to App Search. And we try to make it as easy as possible. We don't want you to have to think too much about how you structure your data or learn too much about App Search before just getting up and running and seeing what the system can do for you. So right here, we're just saying, create a SwiftType client. This is our Ruby client in the Rails application. And then every time one of these business records changes, we just want to send that change to the API. And sending that change to the API is really simple. Again, we don't make any assumptions about your data. We just let you serialize it to JSON and send it in whatever format it has into the API. So I'd like to do that with the existing data here. And essentially what this command is going to do is it's just going to run through the entire database, resave those records, so they ship to the App Search API. So I'm going to get that started. And we should see kind of a printout of what the different records look like to give you an idea about the structure of the data. So I'll slow it down there. Again, you can see things like tags, the location, and actually the latitude and longitude, and some other attributes like, does it have a full bar, things like that. So when you do this, you start getting immediate feedback. So if I come back to this page where I created the engine, if I refresh it, you start to see things reacting immediately. So you start to see that you have these documents that are coming in. It starts tracking like your API operations. So you can trend these things over time and actually understand how things are working. Similarly, we found it's really important to give you insight into how your interactions are working between your code base and the App Search API. So you can come in here and see these are the API calls that script was making. You can open one up and see every detail of it. You see that it was successful. You see it was coming from the Ruby client, and where it was going, exactly what you sent. And also you can verify things like there were no errors in the response. Similarly, we can go jump into the actual documents themselves. So when we come in here, we can see how app search represents the documents, which is a lot like you would expect from the JSON. So you see these different documents, and you can even take action on them if you want to. Like, say you want to remove this particular document. You can do it directly from the app search dashboard immediately. So let's try to search and see how it works so far. So in here, I'm going to type in a search, and I'm going to intentionally misspell it, just so you can get an idea of what app search does for you immediately out of the box. So you misspelled sushi. We understand what your end user meant. We handle it all for you immediately. And again, this takes no extra configuration from you. We just do it immediately out of the box, and you get great results for sushi. Similarly, we know that you can't always trust people to format things correctly. So we have formatted phone numbers, but if you come in here and type in a phone number of a local spot, it's going to still match the formatted phone number in the database itself. So when it comes up, you'll see this result is the top result. One of the things, though, that I want to point out is that it's not all perfect just yet. If we start typing that phone number and just input the 4, we actually see a few things that are matching that may not be ideal. So for instance, we matched on the rating 4. That may be OK, may not be OK. But one that really looks off is matching the prefix of a latitude in the location. It's probably not what we want. And what's happening here is actually we indexed all the data here as strings. And that's fine. It's an easy, quick way to get all the data in the index. But obviously, there's a lot of richness to this data, and we want to be able to use that in the search queries. So it's not a problem. You don't have to resend your data, reformat it, or anything like that. I'm going to jump into the Schema Editor, and I'm going to make those changes live on the index. So rating, I'm going to change it to be a number. And location, I will change to be a geolocation. I'm going to click Change Types, and this is going to kick off a background job that is going to handle the entire reindexing process for you live online. So if you're sending updates, deletes, end user queries to this index during this time, everything's fine. There's no downtime involved. All this happens seamlessly behind the application. So it'll finish up here in a second. And again, it doesn't matter how large your data set. If this takes some time to run through it, your application stays live throughout. So it's already done. And now we can kind of take a look at what this has enabled for us. We have a few lines of code, some clicking around in the dashboard, and really just a few minutes of interaction here. So here's a front end for Food Finder, and this is essentially a JavaScript application that uses our JavaScript client libraries to interact with the App Search API. So from here, we can come in and type sushi and see in this area of New York the different restaurants that show up. It's kind of what you'd expect. We filter down to this part of the map. And you can even do things like feed in the user's location from their browser. Our JavaScript clients can handle that for you and automatically move the map, create the filter, and just filter down to the area we are here in San Francisco. So you'll see the results repopulate both on the map and in the sidebar. And just to give you an idea, we tried to keep this query language as simple as possible. At its core, you're really just sending in the query string. We don't require a lot of complex formatting around that. You can just send in a query string, and we will match it for you. But we let you do things, again, like the geofilters, and try to keep it as simple as possible. So I want to jump back to New York and look at this sushi query again, because I feel like there's some improvement that can be made to the results. So the results are pretty good. They're obviously sushi restaurants, but I'd like to jump back to the dashboard so we can start looking at how we can make changes here. So I'll go into the weights and the boost tab to give you an idea of the different things we can do to impact search results. So I'm going to do 3 things here. One is I'm going to increase the importance of the business name, because more often than not, that's what people are going to be looking for. So I'm going to bump that up, and if you watch the results on the right side, you'll actually see them react to that change, so you can get an idea in real time what this is going to look like. I'm also going to come down and do 2 more advanced things. One is I'm going to promote restaurants based on their average rating. And the second is I'm going to promote featured restaurants based on having the tag featured. So here's the rating one. I'll jump in, and again, you'll see the results reorder as I apply this function. Better ratings mean better ranking in search results. And similarly, I'll apply a value boost to the tags field for having a featured tag, which is something that exists in the Food Finder system. So again, boost featured restaurants, and you'll see them again reorder. Once I save this, everything is live on the Food Finder app in production. So another thing that we deal with a lot in the history of SwiftType is the importance of search analytics. Understanding how people are actually using your search engine is paramount to reacting to those changes and leveraging all these controls. You have to know what's good and what's bad to be able to make these changes correctly. So you get to have a full view of search trends, and again, what's good, top queries, what's bad, top queries with no results. So let's look at what's good and make sure that it's as good as we want it to be. We have the query for brunch here, and if we go in to edit it, we're actually going to be able to curate those results directly. So let's say this second result is actually the result we want in the first position. It's this restaurant called Egghead. All we have to do is take this row, grab it, and drop it on the top. And again, this is going to be reflected immediately if we jump back over here to Food Finder, search for brunch in New York, we should see Egghead at the top result. Similarly, we have the issue of results that are not, queries that are not returning results. So if we jump back to analytics, we'll see that the top query with no results is tavern. Now this can happen for any number of reasons. Some cases you actually don't have data for taverns, but we're searching for restaurants in New York. I have a feeling that we have some bars around there, and maybe they just don't have tavern in the actual corpus. So what we can do there is solve it with synonyms. So we come in here, create a synonym set. I'm gonna make it a synonym for tavern, I'll add pub, and I'll also add bar. So if we save that, and we jump back to the interface here, and I search for tavern, we should see a number of pubs and bars show up there on the right side. So all these changes take effect in real time. We do all the heavy lifting behind the scenes for you because, we want to let you focus on what's unique about your search experience. So this really just scratches the surface of all the things that we can help you do with a product like App Search, but the exciting part of this is that we get to open the beta to you immediately. You can go sign up on the website and you get access right away. And as with any beta, we really would love to hear your feedback. But more than anything, we're just excited to see what you all can build with this. So thank you very much.
Thanks, Quinn. I disagree a bit with the synonym aspect of tavern to pub. I don't think Bilbo Baggins will meet Aragorn in a pub. He'll meet him in a tavern. But seriously, I can't express how excited I am about this product. I mean, I'm impressed by everybody here that have taken Elasticsearch for a ride in terms of try to implement App Search. But after looking at this, which is implemented as a layer on top of Elasticsearch, data is still in Elasticsearch. If you send queries through this layer of APIs, they will get logged and provide you all of these analytics. You can see what level of experience we can give you as the users. So if you've used Elasticsearch historically to go and implement it, I think that you can appreciate everything that you can get now out of the box with the product that we have. If you haven't, and you have an App Search use case, definitely go and check out this product. As Quinn mentioned, SwiftType is a software as a service company. Site search, enterprise search in beta, and now app search are provided as a service. And we're working heavily to also have an on-prem version of them, similar to what we've done with APM. So this is right around the corner. That sums up all the solutions that we've talked about. There's another computer here waiting for another demo. But there's a point that we were hoping to make here, which is basically that for us as Elastic, as a search company, we truly believe that all of these use cases, all of these features, all of these solutions are just search use cases. Search has been almost like degraded 8 or 9 or 10 years ago to something that sums up in how do I parse Word documents version 7.5 in my organization and make it searchable. I'm truly proud of what we've done in terms of taking search as a core technology and being applicable and useful for all of these various use cases. So when we look at everything that we've seen so far and everything that we're going to see down the road, for us as a company, we view all of these as search use cases. And we view all of that being built on top of search as a technology. And we think that that's our special source. And that's what makes what we build special. This is the twist that you see us put on every single problem or challenge that we have when it comes to trying to solve it. And I hope that you agree that this is very useful. you do see how we grow as a company. We grew from Elasticsearch to more products and more solutions and making sure that we're there for you, the users, as you use us. And there's another area that we're growing as well as a company. We as a company provide quite a bit of training experience when it comes to training you to be able to be successful with our products. Even just this conference, we have almost 300 people being trained in the past 2 days on our various products and courses. And we're also revisiting how we do training in Elastic. And you see that this is a bit of a challenge in terms of trying to figure out, okay, where do we start and how do we go? And it's the same way that with SwiftTap, we went back to the beginnings, we also go back to the beginnings with our training. So we're actually introducing 2 courses that are basically restructuring our existing courses, and we're focusing on Elasticsearch. If you're going to use our stack, eventually you'll want to know about Elasticsearch. If you're going to stay at your job and move from one use case, maybe from one team to another that uses Elasticsearch one time for security and another time for logging or an app search, Elasticsearch is the heart of everything that we've built, and we want to make sure that you're successful in it. And then once you've taken these 2 courses, you're going to be certified. So we're going to have a certification that goes and make sure that you can be proud and take it with you as an individual when you move around and being able to show that you've been certified on our software. There's a lot that we're thinking about in this context. How do we then take everything that you've just seen? How do we take all of these machine learning features and APM? How do we take logging and metrics and Kubernetes and how all of that becomes something that you can pick and choose and decide what you want to do? We call them micro trainings. And we're in the process of building them as well and making sure that you can go and learn them, hopefully online or in person. It's up to you and you make the choice. So that's a bit about our training and what we do there. Another important area, and I've talked about it last year, that we do is Elastic Cloud. Elastic Cloud is our SaaS hosted Elasticsearch service. You go to Elastic Cloud and we'll go and deploy an Elasticsearch server for you and manage it for you. We've also introduced Elastic Cloud Enterprise. We see quite a lot of organizations that want to be able to go and manage more than one cluster, want to be able to go and manage hundreds of clusters, tens of clusters, all of these aspects of being able to go and orchestrate an Elasticsearch deployment within your org. Many reasons of why you would want to use it. The challenge that we've had, both for our SaaS service and our on-prem customers of Elastic Cloud, is that you were slightly limited with what you could do. You basically had what we call one slider. This one slider basically controlled how much memory and how much storage you would want to have for an Elasticsearch deployment. And as you see here and what we've done, actually a deployment of a cluster or a deployment of our technology is more advanced than that. What about machine learning? What about different types of data nodes, warm data nodes or hot data nodes when it comes to logging use cases? So actually what you want to be able to do is to be able to have more control over all the various aspects of a cluster when you go and deploy it on Elastic Cloud and configure it. This allows us, for example, to be very aggressive when it comes to logging use cases, and old data can then have ratios of 1 gigabyte of memory to 80 or 100 gigabytes of storage versus recent data that has ratio of 1 to 20 or 1 to 24 because you want results to come back faster. So we've worked over the past year in introducing this feature, and I'd like to welcome Andrew on stage to demo it. Andrew?
Okay, go for it. Thanks, Shai. Hello, everybody. So many of you will be familiar with this page already. It is our current Elastic Cloud Create Cluster page. And as Shai was mentioning, you can create a Elasticsearch cluster on here that has a preset, predefined RAM to disk ratio. And it always goes to the same I/O optimized hardware. And every node has all the roles. So you can't create dedicated master, dedicated machine learning, for example. So while we do use the best instance types AWS and GCP have to offer, a lot of you have asked for more flexibility here. Maybe you have a logging use case, maybe you want to use memory or CPU, optimized hardware, or maybe you just want to run machine learning and APM on hardware that fits. So we have been listening, and we have worked on our newest feature, which will allow you to manage each part of the Elastic Stack individually and to allocate it to specific hardware. So my demo will walk through the logging use case, and specifically the hot-warm architecture. So hot-warm is a well-known pattern in Elasticsearch where you have the newer indices go to more expensive and faster hardware, and you have the older indices that can be moved to what we call warm nodes, which are cheaper usually and a bit slower, but they're better at storage. So I will pick hot warm and click configure. So as you can see, I'm able to already manage each part of the stack right here. So I've got my masters, I've got data hot, I've got data warm, machine learning, and Cabana right now. APM and Logstash are going to be added in the future. So I can go ahead and decide that I want 1 gig of RAM for masters is fine, but I'll put it to 3 zones. And if you saw that, the architecture diagram here has actually updated. So I'll pick 4 gigs of RAM for my data hot, put that into 2 zones, and I'll do the same for my data warm just for now. And 2 zones. So as you can also see that each of these instance configurations is actually going to specific hardware. So the master is going to an R4, the data hot is going to an i3, and D2 and M4, and so different instance types. This is on AWS, but it certainly could be on GCP or anything else. The hardware that we're going to be putting for master or data hot or the different instances are what we've decided is the optimized hardware for that. So machine learning needs a bit more RAM than most, but 1 zone is fine for now. Cabana I'll just leave alone. So I'll go ahead and click create. And we'll wait. And so this is the activity page where you can actually watch this deployment coming online. Deployment has a number of different steps, and I won't actually wait for everything. But I will mention one part here is that with the hot-warm architecture, you will also be able to manage your indices directly in the cloud. So you can tell our index curator, hey, I want to move nodes every week from, or indices every week from the hot hardware to the warm hardware, or whatever you want. So I've already created a deployment that looks exactly like this one, so I'll just go over to that. It would take about 1.5 minutes, 2 minutes to come online. So this is the deployment overview page, and you can see that we have all our nice instances here. So we've got in the different zones that I picked. So we've got data warm, we've got master, data hot, master, data warm, machine learning, so on. What's really cool is I can show you that, well, I can also filter, which is kind of fun. We can show you the allocator, the host that is actually where this instance is living. And I can tell you, or I can show you that that is, what is the instance type of that. So we said that the master was supposed to be running on an R4. So I've opened up this host. And we're going to scroll to the bottom here. And there is the R4 instance type on that host. I can do the same for data hot, for example. So this data hot is supposed to be on some kind of i3 tagged host. And there is the i3 tag as well. So this is a very short, very simple demo, but I think it is extremely powerful what we can now do in cloud. You're able to, by managing each of these individual pieces and being able to throw them to specific hardware, you get a lot more power in your cloud deployment than you've ever had before. All of these changes are coming to Elastic Cloud Enterprise and to Elastic Cloud. To be able to manage all this fun UI, we've actually revamped the user console entirely, so it will no longer look like this. It will actually look like this. It's both Elastic Cloud Enterprise and Elastic Cloud will use the same code base, and you'll get a lot of other fun usability improvements in there. I think that's it. Thank you very much.
Thank you very much, Andrew. So if I had to sum up these features, why have one big hamburger when you can have 3 small ones? Next up, the software as a service. So we provide Elastic Cloud, which is a hosted service, and we've been investing heavily on it. We're basically all over the map. We're running on AWS, so as you saw, you can choose AWS as a deployment option. We're also partnering with Google Cloud, so you can choose GCP and deploy it on Google Cloud. We'll make sure to go and manage all of these deployments, especially the ones that you've just seen with all of those sliders, and in Google Cloud as well. And we've also announced a partnership with Alibaba or Aliyun. So if you want to go and have a managed Elasticsearch cluster in China, you can go and deploy it using Alibaba Cloud. So I'm extremely excited about all of these three partnerships. And basically, it lives up to what we try to do, which is be there for you wherever you are. If you want us to host it for you, we'll go and host it for you. Or if you want to go and run it yourself, you can go and run it yourself. Quickly changing gears, we've done the cause awards a few times. We love people using our software, and we have extra love for people that use it for good. And we, every year, we try to award or celebrate the usage of our software to really try to make a dent in the world when it comes to different aspects of our life. And for that, I'd like to welcome our judge crew. So these are employees in Elastic that have the very, very tough challenge of being able to choose which awards to celebrate. And we'll start with Daniel and next award.
Thank you, Shai. Working at the intersection of child sexual abuse and technology, Thorn really understands how truly powerful technology is. Their products combined have helped identify 6,000 victims of child sex trafficking and even helped rescue 72 victims of child sexual abuse whose images have been distributed on the dark web. Please join me in welcoming the director of the Innovation Lab at Thorn, Ruben Venderdussen. Thank you.
Libraries Without Borders is reinventing the library for the 21st century, and they're doing so for underserved and refugee populations. Please join me in welcoming and congratulating Mark Kramer from Libraries Without Borders.
In the face of a humanitarian crisis, many of us are told to look for the helpers, and that's precisely what Sonny Kim and Maximilian Richt are doing at Refugee Datathon Munich. Since 2015, they have been empowering pro-refugee activists and are now using the Elastic Stack to create dashboards to make it very easy to help in their cause. Please join me in welcoming and celebrating the work of Refugee Datathon Munich.
TB is an epidemic in India that kills 300,000 people a year. Debug is working tirelessly to help bring data together more efficiently so that local partners can better serve the communities impacted by this epidemic. Please join me in welcoming Farid Renair from Debug. Thank you.
Thank you very much, everybody. Yeah.
Not maybe as elegant, but.
So we've come to the last part of our session, I promise. And I want to talk a bit about something very personal to me. I personally, and our company as well, try to spend a lot of time in trying to figure out how do you build a successful company that has a responsibility to all the employees that it has around open source software. And this is obviously a very challenging aspect when it comes to trying to figure out how do you end up doing that. It warms our heart to see companies like Thorns and other being able to just go and take our software and use it for the better good. And we've taken a lot of features, and this is like extremely high level view of features that we had, and we basically go and put them in open source for everybody to go and use, no question asked. But together with open source, you try to think about how do you end up building a successful company around it. And there's challenges. You can go and, for example, have one model, which is, let's go and take and release all of our software as open source and basically make sure that we build a support business around open source. And this has been tried over the last few years. And I always saw challenges in building a support business, only support business around open source. And those challenges, if I had to pick on 2 examples around it, are extremely important to understand in order to see where we're coming from as a company. The first one is, if you try to build a business that only relies on support, you end up hindering your ability to provide great support. If you as a company go and give all your software as open source, and then all you do is provide support, your goal as a support organization is to make sure that people, well, they don't need you anymore. They know enough about the software to go and be self-sustainable. Your goal, if you're really building a great support organization, is to make sure that that's the case. But the problem is that once you teach someone how to use your software and they don't need to teach them anymore, they won't need you anymore. And for all the right reasons, they won't renew with you anymore as a business. So you end up seeing companies that have been built around open source that have not been successful, saying things like, help that customer, but don't help them too much. So they'll still need us when it comes to renewing. Teach them how to restart the server, but don't really teach them around what the actual problem with the feature is. And that's something that we didn't want to do. We don't want to create a system where we build a company that inherently almost like competes with itself when it comes to trying to build a successful business. The other problem with support-only businesses is that when you look at a product, you hopefully want to try to make it both as featureful as possible, but also as simple as possible. Now, if you manage to get to that level of building the most simple product possible, effectively, that's by definition a product that doesn't need any support. So if you're building a business that only relies on support and you have this laundry list of features that you need to pick and choose which one you're going to work on, you're probably not going to choose the one that causes your product to simplify. And that's something that we as developers and as engineers and as an organization prefer not to have a choice at. And we want to always work towards simplifying our products as much as possible. And I won't name any names around products, but you can see products that have businesses that have been built and only provide support around them atrophy towards complexion. And just like being complicated and more complicated, and it's very hard to blame the organization that drives these products because it basically goes against the nature of what the business that they tried to build together with the product that they're trying to develop. Another aspect that you can say, okay, like we're running an open source business, what do we do? Maybe we'll have an enterprise and a community or an open source version of our software. There's a few open source companies that do that. And to be honest, like we also struggled with this version or this model. It does start to sound right, which is basically let's have a few commercial features that are encapsulated in an enterprise version. But it still goes against what we try to have with our users. If you're using the open source version, you should be able to easily upgrade to a version that has the commercial features. If you're using the open source version and then you become a customer of ours, though, you shouldn't feel like you're going and taking a step back. The open source version is running ahead with all the features blazing, and excitement happens, and then you become a customer of ours, and you're stuck with the two-year-old version that doesn't have all the really cool and nice features. You also make silly statements like the open source version is kind of tested, and the enterprise version is really tested. And as an engineer that goes and work, and I don't care if I work on a commercial feature or an open source feature, I'm going to test my code. So it's silly statements that end up, to be honest, putting your engineers in an uncomfortable position of saying, when I develop open source, I don't test it that much. So there's a lot of conflicts also that happens when you try to build an enterprise version and an open source version. The last bit with an enterprise version is that it goes against the idea of openness. If you think about it, there's this open source version, And then there's an enterprise version that's like, fairy dust came over and sprinkled some things on top of it, and suddenly magical commercial features grew out of it. And it's closed. You don't know how it happened. How were they developed? How they got integrated? Which version of am I really using the open source version anymore? Because I don't know how that integration happened. So what we've set out to do since we started as a company is to say we believe that we need to have commercial features in order to make sure that we solve the support-only challenge or catch-22 that you have as a business. But we also believe that the open source needs to remain open source, and we'll just add a layer on top of the open source that is pluggable, that uses official plugins in the open source version that adds these commercial features that you end up using. And this is what historically has been called, or still being called, XPack. It has a few features that goes and get into it. And to be honest, I think we've done a relatively good job in terms of balancing which commercial features we should have in XPack versus all the work that goes into open source. We have hundreds of engineers working every day on our products, and obviously the community around it. And most of the investments go into open source and obviously XPack as well. But even within XPack and within this commercial IP, we do identify two types of features, basically. One of it that we think are applicable actually to a wide range of users, and one that is more applicable to more specialized enterprise-level customers. So we've actually, a couple of years ago, introduced two layers in XPack. One of it is paid, and one of it is free. Still commercial IP, not open source. But if you want to go and use monitoring, that's free. It's part of the XPack basic license. You come to us, you get a license for a year, you start to use it, no string attached, you can just go and use all of these features. And as you can see, we're adding more features to it. SQL and Canvas that we've seen today, for example, are two features that are going to be part of XPack basic, completely free for you to use. You can go and download it and start to use it as part of our products. But we really like to challenge ourselves, and we keep on asking why and whether what we do works and how it works. And some of the things that we've seen is that actually what we're asking you to do is, again, we didn't mean to it, but still created this catch-22 situation for us. We basically told you, listen, use the open source. You can go. You can collaborate with us. You can open an issue. You can look at the source code. You can track your issue and how well it's being fixed. You can communicate directly with the developers, all the wonderful things that you get with open source. You can send us a pull request, and we'll work with you to try to go and fix a bug or something like that. But then you go and use XPack Basic or become a customer of ours, and you're getting a worse experience for that XPack part. The code is closed. You can't open an issue. There's a different issuing tracking system. Actually, the free features that we give you, which we truly believe every single user of our stack should use, is not being used to a level that we would love it to be. And most of it, to my mind, comes because this lack of collaboration, this inability to have the level of collaboration that we believe that we should have with you, even on code that is not open source. So I'm happy to say that starting from the next minor version of our whole stack, we're opening the code of XPack. Thank you. This is something that we have not seen in other companies. So as you can see, open source remains open source, but we're taking all of our commercial IP, machine learning, all of our commercial IP that exists in XPack, machine learning, CSV export, Canvas, all of these things, and we're basically clicking make public on GitHub. And we're going to take that and hopefully get to a level where we collaborate with you regardless of whether you end up being our user or our customer across all of our products, across all of our stack. And that's, to be honest, something that I'm super excited about, because I truly believe that the level of collaboration that we can have, whether it's on open source, or whether it's on the XPack free tier, which is Canvas and so on, is something that to be honest, can make magic happen. So we're taking this software, we're making it open, and we're doing a few more things as a result of it. Because once we make that decision, and by the way, this is almost like an emotional decision that we're making, because we're trusting you, our users, to collaborate with us and make sure that you end up making it happen and making it a reality. But we basically revisited what is our stack at that point. I mean, if everything is open, everything is basically, the experience is exactly the same. The code in XPack is open. It's part of GitHub. It's part of all the development ecosystem that we have. Then maybe we can actually go and revisit what is the product that we have. So if we go and try to go and download Elasticsearch.zip or Cabana.zip, what does it include? And if we're at a point that we think will be successful, which means that all of that code is open, everything is out there for you to go and build and run and experience yourself. Part of it is open source, and part of it is free, and part of it is commercial, and you need to pay money for. Then maybe we can revisit what is a stack. If someone downloads Elasticsearch.zip and downloads Cabana.zip, should they have Canvas out of the box? And should they have SQL out of the box? It's free, it's open, you can go and start to use it. There will always be open source, and I hope that you see the message that we're trying to send here in this visualization. Open source remains the same. Apache 2 license doesn't change. All the features remain the same. Nothing changes in that aspect. But everything above it changes. It becomes more open and more collaborative. And then when we look at it, we can basically say, what is the default experience that you as a user can have? You can go and download Elasticsearch-OSS or Elasticsearch-Apache2.zip and obviously get a purely open source version of the software. Nothing changed. It's the same thing that you could get in 6.2 or 6.3, exactly the same thing. But if you download Elasticsearch.zip, what do you get now as a user? And what you would get is a default experience of all of the free features together with open source with a lifetime worth of license for it. There's no need to come to us anymore to engage with XPack free licenses or something along those lines. It's yours, it's open, you can go and do whatever you want with it. And then on top of it, there's the commercial features that we have, and that's completely opt-in. So we want to be as explicit as possible with you, our users, around when do you go and start to use a feature that you might need to pay for down the road. So you'll have, it will be very clear in the UI. You need to go and opt in and say, I want to go and, for example, use machine learning now. And use machine learning to a level that I opt in, I run it, and then if I like it, I'll go and it will come to us and engage with us commercially as a company, which I've hopefully explained why we need that. So this is a big, this is a big difference for us and a big change for us. And to be honest, a lot of trust that we put at the hands of you, our users. I'm super excited about it. I can't begin to explain how simple this will make things for us. It means that we don't have to maintain a closed branch of our code, or not branch, sorry, a closed repository of our code. It means that everything starts to work together. All of our engineers work in the same way. We just go and collaborate with you exactly the same way, whether you're a user or a paying customer that gets XPack. You can go, if you're a customer, tomorrow, once 6.3 gets released, you can go and open an issue against an XPack feature and track it on GitHub the same way that you do with open source. There's no more second-class citizen when it comes to being a customer of ours versus a user of open source. So with that, I'll end. Yeah, thank you very much. So with that, I'll end. And thank you very much, everybody, for your trust. Thank you for sitting around for an extra half an hour. And I hope you'll all have fun in our party a few minutes from now. Thank you very much. Bye.
Elastic, 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 elastic. Yeah. You can call on support if it's something that's drastic. Yeah. You can sign up for training if you needing practice. Yeah. Better relax. Elastic, 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 and we the open source stack. We gon' get you on track. These beats Cabana lock stash. Elasticsearch, that be a fact. Are we looking at the gold or onto the platinum? Do you know how many nodes? You better go ask them. Elasticon, you better not let it pass them. Yeah, use cases, too many men I cannot even fathom. Search analytics, metrics and logs if you with it. Gotta admit it, you need support.